morning, students. This video is meant for the students of all high school classes, that is 8th, 9th and 10th classes. Listen carefully. This is a study material, or you take it as a content of the topic, important content of the topic, all the important information is being given to you in this topic. So study well and prepare well and make use of this. And I have taken all the important information regarding the subtopic polynomials. Understand? Listen carefully and understand. Try to understand what I am writing on this. Look here. Look at that. We start with the definition of a polynomial. What is a polynomial? An algebraic expression, that is, algebraic expressions containing variables with non-negative exponents are called polynomials. The same, in other words, a polynomial with a variable x is an expression containing the sum of a finite number of terms of the form ax to the power of n. A polynomial is nothing but an algebraic expression. It contains some terms, and it is a sum of some terms of the form ax to the power of n, in which ax to the power of n is an example of a term. What is in the term? What is a? For any real number a is any real number and a is not equal to 0, and n is a whole number. X is the variable. N is a whole number, a is a real number not equal to 0, and x is the variable. All terms are in this form. The sum of the terms of the form x to the power of n. It is an algebraic expression. It is called polynomial. Understand? In general, we denote a polynomial with a variable x with px. Let x is a variable. X may be or y or any z may be anything variable. Generally, we take x is a variable. If x is a variable, the polynomial is called, we denote it with p of x. P of x means a polynomial with x. Understand? Examples. You see, I wrote some examples here. 3x minus 5x, 2x square plus 5, x plus 9, x cube minus x square plus 2x plus 8, etc. It may be any polynomial of the form. Understand? And first of all, let us know what is a polynomial. Now we studied about the definition. Now we must know something more about the polynomial. First of all, degree of a polynomial. What is meant by degree of a polynomial? The highest power of the variable in a polynomial is the degree of that polynomial. You see, you find number of terms, and in that terms you find the exponents. See, the highest exponent of a term will be taken as the degree of the polynomial. See this example, see 5x, 2x, x plus 2, x plus 5. See, in all these polynomials, you find power of x is 1. Power of x is 1. So therefore, it is a first degree polynomial. And x square plus 9, minus x square plus 5, 3x square plus 8, x square plus 2x plus 3, second degree polynomial. See, in all these expressions, in all these algebraic expressions, you find the highest power is 2. Therefore, it is a second degree polynomial. And in this, you see, in these 3, in this highest power is 3, therefore it is a third degree polynomial, and so on. If it is 4, fourth degree, if it is 5, fifth degree, like that. In general, this is an nth degree polynomial. And its general form, or the general form of a polynomial is an x to the power of n, an minus 1 x n minus 1, an minus 2 x n minus 2, a1 x, last one a0. This is called the nth degree polynomial. Understand? This is about the degree of the polynomial. Understand? And we will continue in the next point. Not only degree of the polynomial, we find it. We find in a polynomial, you may find one term, 2 terms, 3 terms, 4 terms, like that. So it depends on the number of terms. We call it with different names. Note the following. A polynomial which contains one term is a monomial. If it contains 2 terms, it is a binomial. It contains in 3 terms the trinomial. Just only for these terms only we have separate names, but it may be 4 terms, 5 terms or 6 terms or 9 terms. All are polynomials. In general, all are called polynomials. If a polynomial contains 1 term, it is a separate name monomial. 2 terms binomial, 3 terms trinomial. That's all. Maybe 3, 4, by any number of terms, all are polynomials only in general. We call them. And now observe these expressions. Observe these expressions. They are also algebraic expressions that are called polynomials. In these expressions, you find this is x, this is minus 4x, this is 2x square, this is x minus 5, this is x square plus 2x plus 1, this is 3x cube plus minus x square plus 2x plus 5. See, in all these polynomials or the expressions, in all the above, you find only one variable x. See, in all the terms, you find only x. Hence, these are all polynomials in one variable denoted by px. All these variables, in short, we call them a polynomial in x, a polynomial with a variable x. In short, we can say it is with px, p of x. That is, p denotes polynomial, x is that is variable in that polynomial. So it is denoted by px. Now we are talking about the zero of a polynomial. So let us see. For different values of a variable, we get different values for the polynomial. In some cases, the value may be 0 for a particular value of the variable. That is, for all, not for all values. For some values, the value of the polynomial may be 0. Therefore, so for a particular value, about that, we must know what is this particular value. Therefore, the 0 of a polynomial px is the value of x for which px is equal to 0. See, in every polynomial, for a particular value of x, the value of px may be 0. That particular value is called the 0 of the polynomial. The standard form of a linear polynomial in one variable is ax plus b. Let ax plus b is 0, implies ax is equal to minus b and implies x is equal to minus b by a. Here you must note carefully. Therefore, minus b by a is the 0 of a polynomial ax plus b. Remember this point carefully. Minus b by a is the 0 of a polynomial ax plus b. Note that a linear polynomial in one variable has only one 0. That is also another point you must note. Every linear polynomial in one variable has only one 0. Also note that 0 of ax minus b is b by a. Here ax plus b is 0 is minus b by a. If ax minus b is, it is b by a. Look here. Dividing polynomials. As we divide a number with any non-zero number, we can also divide a polynomial with any other polynomial. Division logarithm, already studied in our earlier chapter. Dividend is equal to divisor into quotient plus remainder. This is division logarithm. This states that any given polynomial px and any non-zero polynomial gx, there exists a polynomial qx and rx such that px is equal to gx into qx plus rx. This is according to this division logarithm. Even in the set of polynomials also, let px and gx are any polynomials, px is equal to gx into qx plus rs. This is a polynomial. This is gx, another polynomial. This is quotient and this is remainder. That is here. This is divisor, this is quotient and this is remainder. This is the given polynomial. Look here. Remainder theorem. If px is divided by a linear polynomial x minus a, the remainder is p of a. That is remainder theorem. Again I am repeating, if px is divided by a linear polynomial x minus a, the remainder is p of a. Proof. Let qx and r are the quotient and remainder respectively when a polynomial px is divided by a linear polynomial x minus a. By division logarithm, see the same I am writing. Dividend is equal to divisor into quotient plus remainder. That is division logarithm. So accordingly, Px is equal to x minus a into Qx plus r. That is, therefore Pa is equal to a minus a into Qx, and that is P of x, this is P of a minus a into Qx plus r, that is r. So this will become 0, 0 into this one 0 plus r. So P of a is equal to remainder. That is remainder theorem. Now factor theorem. If x minus a is a factor of Px, then P of a is equal to 0. So that is factor theorem. If P of a is equal to 0, then Px is equal to x minus a into Qx. If Pa is equal to 0, then Px is equal to x minus a into Qx. You see? And this is a dividend, and this is dividend, this is divisor, and this is quotient. Understand? If Pa is equal to 0, which shows x minus a is a factor of Px. If you multiply this, the product of these two is Px. So therefore, x minus a is a factor of Px. This is about factor theorem. Again, if x minus a is a factor of Px, then P of a is equal to 0. And with this, from these two, you observe these two these two points, these two important information about these factors. Factor of a polynomial. Here, let Px is equal to ax cube plus bx square plus cx plus d. Follow me. Let Px is equal to ax cube plus bx square plus cx plus d. If x minus 1 is a factor, then P of 1 is equal to 0 as per factor theorem. If x minus 1 is a factor, then P of 1 is equal to 0. If you implement in place of x, that is, after finding P of 1, you get a plus b plus c plus d is equal to 0. It shows that sum of the coefficients of all the terms of polynomial is 0. That is, so without any calculation, you can, if you are able to find the sum of all the coefficients, of all the terms, if it is 0, then automatically you can understand, you can say that x minus 1 is a factor. Once again, sum of the coefficients of all the terms of a polynomial is 0 only if x minus 1 is a factor. So, without any calculation, you just kindly first you find the sum of all the coefficients. If it is 0, automatically you can say that x minus 1 is a factor. Next, let Px is equal to ax cube plus bx square plus cx plus d, and x plus 1 is a factor of Px only if P of minus 1 is equal to 0. This is according to this. So now find, let P of minus 1, a into x cube. So put minus 1 in place of x. A into minus 1, b into 1, c into minus 1, and d. See what will happen? This is minus a, this is b, this is minus c, and this is d. So automatically, if we simplify it, b plus d is equal to a plus c. What does this mean? See this, you can understand, you can write that sum of the coefficient of even powers is equal to the sum of the coefficient of odd powers. So this is also without any calculation to find whether x plus 1 is a factor or not. Just simply find the sum of the coefficients of odd powers and sum of the coefficient of even powers. If both are equal, the sum is equal, both the sums are equal, then you can say that x plus 1 is a factor. Again I am telling you, sum of the coefficients of even powers is equal to the sum of the coefficient of odd powers. Then x plus 1 is a factor. These are the two important points to note. It will be used, these two will be useful in factorizing the polynomials in future. Now we learn the factorization of a polynomial. Factorization of the polynomials. Now, by factor theorem, we can decide a given linear polynomial is a factor of a polynomial of a higher degree. See, let us examine x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. So, you see the solution. 0 of x plus 2 is minus 2. Now, we have px is equal to x cube plus 3x square plus 5x plus 6. P of minus 2 is equal to, so now substitute minus 2 in place of x, minus 2 whole cube, 3 into minus 2 whole square, 5 into minus 2 plus 6. And after simplification, we have these numbers, and after simplification, we have 0. Sum of all these numbers is 0. So we have p minus 2 is equal to 0. So by factor theorem, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Since p of minus 2 is equal to 0. So observe these things. And now let us learn how to factorize a quadratic polynomial of the form ax square plus bx plus c. So now observe the product. First of all, observe this product. This is sum of the product of these two binomials, x plus a into x plus b. So and the product of these two binomials is x into x plus b plus a into x plus b. This is the method. Say x square plus bx plus ax plus ab, and simplifying. So you make it simplify one step by another step. X square plus x into a plus b plus ab. And see, the coefficient of x is sum of the constant terms, and this is a product of the constant terms, sum and product. So coefficient of x is sum of a and b, and the product, and c is the product of a and b. See this product, x minus a into x minus b is equal to x into x minus b minus a into x minus b. See, after simplification we have x square minus bx, that is x into x minus b, x into x, x square, x into minus b minus bx, a into x minus ax, a into minus b, that is minus a into minus b plus ab. See, the next step is x square, you take the common x, that is the minus x into a plus b plus a plus b. See, you observe these products of binomials in the above two cases. The coefficient of second term is the sum of the constant terms, and the constant term is the product of the constant. And a constant term in the product is product of the constant terms. This is. So this is useful in factorizing a quadratic polynomial. What is this a plus b? This is sum and this is product. Understand? These two observe. And now find the factors of the quadratic polynomial. There are two different types of quadratic polynomials are here. See, and here the coefficient of x square is 1, here the coefficient of x square is 2, here greater than 1. So in this case, just simply you take the constant term and resolve it into two factors such that their sum is equal to the coefficient of x. In this case, you find the product of these two, and you find the factors of that product such that the sum is equal to coefficient of x. And this is, you see, 6 is 3 2s are 6, 3 into 2. See, this is plus 6. Here we have minus 5. So minus 3 into minus 2 plus 6. Have plus 6 into minus 5. Minus 3 minus 2 both add, you get minus 5. So in that way you have to resolve the factors. So this is x square minus 3x minus 2x. Same 5x I wrote like this, minus 3x minus 2x plus 6. And x into, take x common in these two, x into x minus 3 minus 2 into x minus 3. So x minus 3 into x minus 2. These two are the factors of this x square minus 5x plus 6. So in this, observe this second one, 2x square minus 7x plus 3. And the product is 2 3s are 6. Take 6 and resolve into factors. 3 6 into here we have 7. So to get 7, we take these two factors, 6 into 1, 6, and 6 plus 1, 7. So in such a way you have to find the factors. Now 2x square plus 6x plus x. See, we write 7x like this plus 3 and make 2x as common, 2x into x plus 3 plus 1 into x plus 3. So x plus 3, x plus 3. X plus 3 into 2x plus 1. These two are the factors of this quadratic polynomial. Algebraic identities. Algebraic identity is an algebraic equation that is true for all values of the variable. These are useful in finding the factors of the given polynomial, in resolving into factors, given polynomial, given equations. See, x plus y whole square is identically equal to x square plus 2x square plus y square. So that is, this is true for all values of x and y. Next, x minus y whole square is identically equal to x square minus 2x square plus y square. x plus y into x minus y is equal to x square minus y square. X plus a into x plus b is identically equal to x square plus a plus b into x plus ab. X plus y plus z whole square is identically equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. And x plus y whole cube, that is x plus y into x plus y into x plus y. It is identically equal to x cube plus 3x square y plus 3xy square plus y cube, or the same after simplification you get x cube plus y cube plus 3xy into x plus y. See, in these two you take 3x as common, then you get the answer like this. So both are correct. Here also x minus y whole cube is identically equal to x cube minus 3x square y plus 3xy square minus y cube, or x cube minus y cube minus 3xy into x minus y. There are two answers here. See, x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx is identically equal to x cube plus y cube plus z cube minus 3xyz. X cube plus y cube is equal to x plus y into x square minus xy plus y square. X cube minus y cube is identically equal to x minus y into x square plus xy plus y square. See, these are the algebraic identities useful in finding the factors of a given polynomial.